So, welcome everybody to today's webinar. We got duct sealing, leakage testing, and ventilation, what code requires. So, as always, this webinar is being recorded. It will be uploaded to our YouTube channel, where you can find by searching SPEAR on YouTube, or you can go directly to our website at eepartnership.org. Under our news section, you'll find the resources page. Once you're on the resources page, there's a link that goes directly to our YouTube channel. So there's well over 150 videos from a variety of topics that are there. There's some feedback on some surveys that I'm getting from some of the webinars that there are some older videos that are on our website or on our YouTube channel that actually addresses kind of what you're looking for. So you might check with that a little bit and see if there's some information there that you can find that's helpful. Today's webinar is eligible for IECC CEUs. You must be present for at least 3/4 of the presentation. Within about 72 hours, you'll receive a course evaluation email from Kathy Lawrence. Please complete the survey and send it back to her to receive your course completion certificate. That will contain the course ID and title number, or course ID number and the title that you'll need when you're reporting your CEUs to ICC. Lastly, the chat feature is open. I will be reporting any technical difficulties that you might be experiencing in the presentation there, and the Q&A feature is open as well. And we'll go through questions as they arrive in the Q&A. So by all means, I want to be going a little bit slower. We don't have a lot of slides today, but we're going to go a little bit slower and dive deep into some of these topics. So feel free to just post a question there. If you're new to SPEAR, if this is your first time on one of our webinars, or you're new to what SPEAR does, we provide trainings, webinars in person, field training. I do phone calls for discussions and topics. We can do Zoom call one-on-one with the city and or inspectors to talk about what we're looking at. I also can help with IECC test prep as well if anybody's looking to be certified. I can answer questions regarding the energy code, ASHRAE 90.1. That's any versions of the energy code all the way from 09 all the way to the 24 that's rolling out in some cities near you today. I'm happy to help in any way that I can. We also assist cities with their adoption of the 21 or the 24 as it's moving forward. We can discuss some of the additional amendments that we're seeing around cities as they're adopting it that can kind of lessen the impact of the adoption for your building code community. So my contact information will be at the end of this presentation. Please feel free to share that and have anybody reach out to me has any questions. If you're a city building official or plan reviewer, if you have a specific question from a builder and or developer or designer that you can't quite answer, feel free to share my information. I don't mind discussing that with them and see if we can come to a resolution. So thanks again for being here. We'll dive right into this. So why duct test? And we've gone through some of this in previous webinars. But it's always good to kind of readdress. And I think there's some things you're going to learn that's new that you might not have learned in previous webinars. But just the duct test, it's a critical component of the HVAC energy code compliance because duct leakage can significantly impact the energy efficiency, indoor air quality, and, of course, occupant comfort. If someone in the home is not comfortable, they will be changing the thermostat to make it so that they are comfortable, and that raises energy consumption. So proper testing ensures that HVAC systems perform as designed and then reducing energy waste and improving overall system efficiency. I put effectiveness there, but it's efficiency and effectiveness. So according to US DOE, duct leakage is typical for homes accounting for 20 to 30% of total HVAC energy loss. Now that's probably based on existing houses as well. New constructions, of course, if you're having new construction being built, there are duct testing guidelines that need to be followed, and we'll talk about that a little bit later. What's the allowable limit for leakage on duct testing? So according also to the Energy Star, experts estimate about 20% of the conditioned air does not make it to the room or space intended due to leaks, holes, or poorly installed ductwork. And we've talked about that extensively on previous webinars about how crushed ductwork or kinks or sharp bends can actually reduce efficiency, comfort, all of those and the above. So they've estimated about 20% don't make it. So if you're looking at a 1600 CFM 4-ton system, then you're looking at 20% of that's not making it to where it needs to be. And that leads to pressure imbalances that we'll talk about in the next slide. But a DOE study also found that 37% of homes also do not meet duct leakage requirements. There are a lot of areas that still, even in Texas and Oklahoma, that may not require duct testing. And then there's other states throughout the country that do not have duct testing requirements, or they don't even have an energy code. So that's kind of how they estimate that part of it. This can estimate or estimated to represent roughly about 44,000 MMBTUs, which is estimated to be about $832,000. That's probably an older figure based on a lower price of kilowatt. It's probably just all it's done is rise, or it was rising since then, or it's gone up since then. So as we talked about this in previous webinars, but leaky ductwork equals pressure imbalances throughout the home. This picture you see here is kind of a simplified version of what that looks like if you're looking at a home and you've got a branch and trunk and branch system, typical to what you see in some flex ducts and how those things are run. But leaky ductwork, you can see that there's really not a consistent temperature throughout the house. The one end on the top right is 73 degrees. Then you've got 80 in that one little room to the side. Then you've got 76, 78. It's all over the board, and that can lead to orientation of the home. There's a lot of factors that can go into that, but leaky ductwork contributes to that heavily. So leaks in duct systems can also pull dust, allergens, pollutants from the attic, from crawl spaces, from basements. Poorly sealed ducts create pressure imbalances, leading to hot and cold spots. Also, poor humidity control. So if you've got leaky ductwork in the return side, you're not pulling out as much as you need to. You're going to have humidity issues as well. And of course, that leads to overall discomfort for the occupants, which means they're going to change the thermostat, which means they're going to increase the energy consumption to try to heat and cool the home. And that's why we do designing of the system, manual J, manual S, and we go through all of that. And that's why it's important in the code is to get these things right. And then you test and validate that it's actually getting to where it's supposed to. So, of course, there's a couple of different pressure issues that can happen. If you've got more leaks on the return side, then you're going to be overpressurizing the house. You're basically forcing conditioned air into the walls, inside the sheetrock or through the sheetrock or around the sheetrock or through the plugs in the wall, the switches in the wall. And then, of course, if you have just the opposite and you've got more leaks in the supply side and it's actually leaking in out of the conditioned space, now you're depressurizing the house and just the opposite's happening. You're pulling air and moisture. We call it infiltration, is coming through the air barrier and any cracks, crevice, and holes that it can find, and it's permeating into the home itself, and that's depressurizing the house. What you'd like to see is balanced. That's not real world. If you've got an air that's blowing outside or a wind that's blowing outside, one side of the house will be slightly pressured, the other side slightly negative. But when you have the HVAC system running, you hope that it's actually taking out as much as it's putting in, and it's leading to a balanced system instead of an imbalance in the system. And you'd be surprised that's probably happens in probably 85% of the homes, if not 90 plus, or they have pressure imbalances and comfort issues just due to the fact that it's not the right supply air equaling the return air. So who can do the duct test? I've been asked this a couple of times. It's coming from third party for over a decade, I always, just getting into this business, I assumed that that's my job. That's what I do. That's why we're going to work for the builder. This is what we're going to duct test. But the code doesn't really specify that. For envelope leakage blower door test, code states that testing shall be performed by an approved third party that's approved by the code official. In reading this requirement you see on the page here, it doesn't have a specification for a third party, which means testing, yes, can be done by the HVAC contractor, but there's a lot of caveats and asterisks that I would add to that. So if the HVAC contractor is approved by the code official to perform the test, they still must be following the ANSI ASHRAE or ANSI ResNet IECC 380 or the ASTM E1554 for testing and determining air leakage. That's kind of what this says at the very beginning in blue, and then you have how the test can be performed. It can be performed at rough-in, that's prior to sheetrock, and you've got post-construction, which is going to be close to the final when the house is being commissioned and close to turning it over for a CO. And so this is just telling us the pressure that needs to be pushed across the system, either in a negative or a positive, but it needs to be 25 pascals. It's not a lot of pressure. It's based on relatively the pressure that the system will be achieving when it's actually running. And so they kind of what you're trying to do is mimic that with doing the duct testing, and then you're looking for how much air is actually making it out of the system. And of course, at the bottom, you'll see it says exemption or an exception here. A duct that's air leakage test shall not be required for ducts that serves ventilation systems only and are not integrated into the duct serving the heating and cooling system. So we'll talk about that more at the very end, but mechanical ventilation, if you have ducts that are tied into the return plenum, then those are subject to testing. If it's not, and it's standalone and it pushes the air into the home without running through the system, then that's exempt from actually having to be tested. The biggest issue with allowing, I want to say HVAC contractors, other contractors that are not a third-party certified energy inspector to perform the tests, is whether the results are coming from equipment that's been calibrated using the interval schedule required by the manufacturer based on type or model of each piece of equipment, including the pressure gauges, which we call manometers, and of course the fans that are being used. The manometers used for these tests are pricey. The newer ones are fully digital. They're subject to less calibration issues, but the older styles have internal components that just one drop on a hard surface like concrete can damage the internal components, requiring recalibration or repairs, or at the very least, it becomes wildly inaccurate. And you may not know it by just dropping it. There's no way to tell if that is accurately being done. So this is the TEC's, the Energy Conservatory's calibration schedule. I could not locate one for Retrotech. There's two that's out there. It's TEC and Retrotech. But it shows on here that the DG1000, which is fully digital, the DG8, which is also fully digital, now has interval schedules of 4 years. It used to be 2, and that's done by the factory. So factory calibration is required every 4 years. Most, if not all, of the manufacturers of this equipment will put a sticker on the back that actually has calibration date of when it was done, and then you just kind of add 4 years to that and say, well, that's when it should be calibrated. If you see this and it's already expired past that 4 years, then it's going to be the fact that these things are probably inaccurate or could technically be inaccurate. And then, of course, the older style, the ones that have older components in it that have little diaphragms in that, the DG700 and DG500, still has an interval of 2 years, and that's factory. Again, it does also have to be field calibrated, which means the tester doing the testing also has a procedure that they do that they can field calibrate against a known accurate manometer, and that's basically you're just comparing its value and you're saying, yeah, that's within tolerance and you're good to go. But that has to be done on a yearly basis. And then also the fans being used are also required to be calibrated from a field calibration standpoint by the tester, and that's on an annual basis. Most of the time there's not stickers or dates on those, but at the very minimum, each one of these third parties should have a recording or a spreadsheet or a way to record when those things are going to expire and when's the next calibration date for all those fans, and need to make sure that they're logged and recorded for QA purposes at all times. And of course, Retrotech is the other one. This is kind of what their equipment looks like, and then we'll see what TEC looks like on the next one. They look very different from one to the other. Both manufacturers, as I said earlier, have stickers on the back of those manometers that are when the last calibrated by factory. Retrotech makes it very easy. They put a portal link for the fans and the gauges where if you just have the serial number, you type it in and it tells you when's the last time it saw the factory calibration done. And so this is kind of their two portal sites that you can go to actually put that in for either fan and or gauges. And so that's easily done, and even a code official could go on Retrotech's website and just verify that if they needed to. And this is kind of what TEC's equipment looks like. This is what I was used to. I used that for over a decade. The far left is their DG700, and the center is that DG8, and then DG1000 is on the right-hand side. That's fully digital. And then, of course, you got what it looks like for blower door fans and then the duct blaster fans as well. TEC does not have a portal to verify calibration dates. You'd have to rely on the stickers on the back of those gauges. For fans and things like that, the only real way to check is to call TEC and ask them when the last time it may have been into the shop. But as I said earlier, fans, unless they're damaged, the fans do not normally have to go back to factory for calibration. It's just done by the tester. And it's It's extensive. I mean, you balance it with a straight edge, and then you do a pressure test with depressurizing of the system, and you make sure it's holding pressure. That way, there's no air leakage inside the system. If these things have little pinholes, and they do determine that they'll have pinholes eventually in these, now your tests are inaccurate. And of course, as we said a second ago, they must also be recorded in what they call a calibration log. If you're a HERS rater or a BPI or BSI, you're going to keep these logs and you're going to turn these things in when you have your QAs done. They need to see those usually on an annual basis to make sure that you are indeed using equipment in the field that are kept up to date, have been field calibrated, and also are on factory calibration schedule. So what's required by code? We've looked at it a second ago. We saw this language a little bit a second ago, but I just want to reiterate again. The testing requirement is that the tester must follow the ANSI ResNet ICC 280, oh, sorry, that's 380, and the ASTM E1554 standards. These standards will state exactly how it needs to be tested from the phase of construction to the test pressure that's being used. It also states what can and can't be done during the testing, and we'll talk about that a little bit more later. But it means that you can't tape things up that normally are open. You have to, you're going to tape off boots and or HVAC vent grills at a final if you're going to do testing at final, but you can't manipulate mechanical ventilation if it's integral part of and tied into the duct system. You can't just tape that off to eliminate it because you know it's going to be a problem. You can't tape that to eliminate it to actually run the test. There's procedures that has to be followed to do that. We've already read the second one. And then, of course, required by code, what's required to be sealed on a system. If you're looking at duct sealing requirements, it comes from the IMC or the IRC, the mechanical code or the residential code. In the IRC, it's found in section 603.9, and the IMC, it's found in M1601.4.1. I'm sorry, I said that backwards. It's 603.9 of the IMC and M1601.4.1 on the IRC. It dictates that air handlers are allowed to leak, but they must follow an ASHRAE 193 for their standards of leakage by the manufacturer. So ducts, air handlers, filter boxes must be sealed. Joints, seams shall comply with either the IMC or the IRC. Air handlers shall have a manufacturer's designation for an air leakage rate not greater than 2% of its designed airflow. And that's, of course, according to the ASHRAE 193. And there are the two sections that you find what's required to be sealed for the system itself. So as an example for that, if the system's allowed to leak 2%, I usually bring this up when I just do some, like if I did energy inspector training, it's just to make them understand that, yeah, we're testing the duct system, but we're also testing the entire system. So if the system is allowed to leak 2%, and you see this example here, it's a 3-bedroom, 2-bath, 1-story, 1,850 square feet, using a 5-ton system. That's probably oversized in my opinion, but I just put that as an example. 2,000 CFM. The total duct leakage allowed by the 2021, which is 4 CFM per 100 square feet or 4%. You're looking at 40 CFM, I'm sorry, 74 CFM. Allowed to leak 2% on the system is that the mechanical system can leak 40 CFM. That Energy Stars looked at that, and now Code's looking at that as maybe that's the bare minimum, that if you can't get that, if the system is very small, then you can top it out at 40 because you're not going to get an extremely low testing number. And that's kind of where this is coming from. But what's left over for the duct system or duct leakage is 34 CFM. Now that's perfect world. That's if the air handler's leaking 2%. Most manufacturer or installers go to great length, as you see here in these two pictures, as they seal up every single thing that they can find on that equipment, and they lower that 2% to even lower. But just from the manufacturer standpoint, if nothing was done except just putting coils onto it or putting plenums onto it or filter boxes onto it, just that piece of equipment's allowed to leak 2%. So duct systems have to be really installed correctly. They have to be installed as tight as they can get to actually overcome what's already kind of allowed to be leaking. So as I said earlier, most HVAC contractors will do their due diligence. They'll actually seal all these things up. Manufacturers send out seals and grommets for the intentional openings of the unit, but a lot of times these things are tossed out in the trash. They're not properly installed. And so what you see here in this picture is them just going to an extra mile and just adding mastic to that stuff just to get it sealed up like it should be. And of course, requirements by the code. Right now, we've got most cities in Texas, or a bunch of cities in Texas, are on the 2021. Currently, right now, this is what it says for duct leakage allowance. Is even though you're doing a rough-in test or a post-construction test, you're still looking at 4 CFM per 100 square feet of conditioned floor space. We're looking at, we just always call it 4%. And then, of course, if the air handler is not installed, then it's now squeezes that target down to a 3 CFM per 100 square feet. This was kind of easier to follow. The older code used to have 1 leakage rate for rough-in and 1 leakage rate for post-construction because they knew it would probably leak a little more at post-construction, so you had to have tighter at the pre. But most people don't duct test twice. They do it once. They'll either do it at rough-in or they'll do it at final. And that's usually how that's done. So now we've got both targets are set the same unless the equipment is not installed. Then, of course, also now new to the 21 is even if you have ducts in conditioned space, they still have to be tested, but they're allowed to leak basically double the leakage of what is allowed by one that's in an open space or out of the conditioned space. It's 8 CFM per 100 square feet of conditioned floor area. So a lot of times that's easier said than done. So back in 2015, the DOE had a study on residential homes in Kentucky. The duct systems that they were looking at were 100% within the conditioned space. And due to the fact that it's on the 2018, they were exempt from being tested. So the study just wanted to find out if they're exempt from testing, how bad are they? So not surprisingly, all 24 homes tested had a higher leakage rate than what was allowed by the 2018 on the ones that were exempt from being tested. So it was much higher than 4 CFM per 100 square feet. And then of those homes in the study, the others that they tested that were required to be tested, those actually were half the rate that you have allowance in there, half of what the ones that were exempt from testing. So the main thing to take away from that is if it's not being validated and it's not being tested, a lot of times that means it's not actually going to be sealed properly as well because nobody's validating and going back and checking that. So that's kind of why code is now caught up to, well, even if it's in conditioned space in an encapsulated attic, you're still going to test it because we need to make sure that it's getting to where it needs to go and not just profusely leaking into an attic that, yes, it's part of the conditioned space, but it's not really going to help to condition the house itself. And you can lead to pressure imbalances and indifferences because it's leaking outside of the comfort zone of the home. And also now required by 2024, this is something that's kind of new. It's talking about total duct leakage. So we called it TDL, total duct leakage. You're measuring the entire duct system and the HVAC equipment. All of that's accounted for to have your test results. There's also used to be one called leakage to outside, which we called LTO. That was used for ResNet and showing code compliance. It used to be in the code. But what you did was you actually set a blower door up and you pressurize or depressurize the house to 25 and then you equalize the pressure in the ducts. And then so the theory was everything that's leaking is leaking outside of the envelope because everything's at an equal pressure. What's not as an equal pressure is what's outside of the envelope. So that was and used to be allowed to say, well, we did a leakage to outside, which means I'm not getting penalized for what's leaking in the home. But it's no longer allowed. Now they want to just know what's the leakage to the entire system. You no longer have a leakage to that. But in the 24, it was kind of addressed because there are people still using the ResNet's 380 testing to be performed for performance or ERI. So if you're familiar with performance and ERI, the testing scores can fluctuate as long as it's trade off with other things that's there. So, but the code now says, and someone's wrote this in here and proposed this, it made it into the code, is if you're using LTO, leakage to outside testing results, it's not permitted to be code compliant. However, you could use it in your software to do energy modeling calculations. So it's just a small way to say, I know a lot of times that's going to confuse some of the cities. It's just going to be that you have to pass the total duct leakage test. You cannot really use a leakage to outside for compliance. So in other words, the duct system test results must meet what you see on the next slide that we'll look at for allowable limits. But when you're doing modeling, you can do that. I know it sounds like it might be a loophole that they're getting through, but when we talked about in previous webinars about doing energy modeling, your home that you're building and the numbers you're putting in is being compared to a house that passes code. And if code doesn't allow a leakage to outside, then what it's doing is it's comparing it to your total duct leakage allowance. And of course, that's going to be harder to do than it really just sounds. So they're not really taking an advantage of anything. But what's new to the 2024 is now it's gone into just not just verbiage, it's gone into here's a table for you, but it now is varying on how big is the house. If it's homes that are less than 1,000 square feet, then you have one way that you're going to do it. If you're going to do 1,000 square feet or more, now it's a different way to do it. If you have 3 or less returns to that system, then you've got a different target. If you have 3 or more, you now have a different target. So it's gotten complicated. Let's just put it that way. So it's no longer just solely based on square footage. Used to it was just what's 4% or 4 CFM of the square footage of the home. And now we've got smaller homes. It's harder to get ducts to pass on very small houses. So they've, as you see to the far right, it's 1,000 square feet or less, then we have a top out on the allowance. It's not going to say 3 CFM or 4 CFM per 100 square feet. It's going to flat out say 30 or 40 or 60 or 80, depending on what you're looking at. But it addresses the space conditioning is either is installed or isn't installed. We're still looking at 1,000 square feet or more. If you have less than 3 returns, you're still looking at 3 CFM per 100 square feet. If it's more than 3 returns, and when I say returns, it's dedicated returns that's tied into the system. It's not jump ducts. It's not transfer grills. It's not bypasses through the door. It's got to be tied into the system. So if you have bedroom 2, 3, and 4 have jump ducts, and the primary bedroom only has a dedicated return, well, that's 1. That's not 4. And so that's how it's kind of based on. But if all components are in, then you've got 4 CFM per 100 square feet for 3 returns or less. 3 returns or more, you have now 6. And as you can see, it just keeps going with that. And looking at space, if it's inside conditioned space, now it changes. Instead of just 8, it's now 6 if it's no equipment installed and less than 3 returns. So it's not as easy as it sounds. But as you notice at the very bottom in that center column, we've got 12 CFM allowed. We haven't really seen that as an allowable leakage since the 2009 code. But again, that doesn't make it any easier. It's still going to be difficult to get there, per se. And then as a refresher, the proper way to add mastic to flex seal or flex ducts and looking at collars and connections is thick as a nickel. 2 inches inside of each of the collars or on each of the collars, 2 inches deep from the edge of it. And then, of course, using zip tie or 181 UL approved tape and or putting more mastic on that. A lot of people just put zip ties and then put mastic back over it. Takeaway here is if you can see through that Mylar liner and you can see brush strokes, that's not a good sign. That's not sealed as it should be. And then, of course, return seal boxes. So looking at returns, if they're built out of framing, if they're built out of sheet metal, if they're built out of OSB board, if they're just pushed directly on top of the sheetrock, you should see tons and tons of mastic on all the seams. Can't say this enough, it should be heavily painted with mastic. All the joints, all the seams, all the connections of where that thing goes together. The one in the center, to me, looks completely messy, but it looks like it's the best job. They've even mastic around the collar where the teeth stick in through the box. The one on the left and the right, they didn't, but they've hopefully sealed it very well on the top side, what you can't see from the attic side of that. And of course, testing procedures, when you're looking at that, if somebody's familiar with some of this, is it can be done at rough-in, and this is what it looks like to be doing for rough-in. Guadalupe, I see that your hand is raised. Let's see. Guadalupe says, I see mastic on the right photo, also on the insulation. Is that required? Let me go back one. So that's probably Yeah, in this case, yes, that's duct board that you're using. So it's basically a crushed, kind of hardened insulation that's being used. It's so the box is being made out of duct board. And as we see, if you're looking at fibers, that air can move in and out of that insulation. So good point, good catch on that part of it. If you've got a breathable material like insulation that's surrounding these boxes, in my opinion, they should also seal those fibers up. You should just be seeing the flat surface of the insulation. Good point. Thanks for the question. So this is kind of what it looks like for doing rough in testing. As you see there, you got ducts strapped to that, and it's actually tied to the return. And then on the right-hand side, you see the manometer. I know this is probably hard to see, but if you look at the quadrant on the left, the big number that says negative 24.9, that's pascals. That means that the tester got it as close to 25 pascals as he can. However, these manometers do have a setting that says at 25. And I know you probably can't see that. It's right below that 24. There's a little at symbol with 25. These things have internal calculations that even though you're at 18 pascals, it's giving you a number on the right hand side that they're estimating. Well, if it was at 25, this is what I estimate it would be. That's still an allowable testing. If it doesn't say at 25, if you see my cursor, if it doesn't say at 25 here or at 25 here, that means you need to be as close to 25 as you can to be accurate due to the procedures that you're following. If it says at 25, then you have leeway on the left-hand quadrant. You have leeway in the fact that it can be different. But the number on the right is being calculated internally that you're getting that number is pretty close to accurate as you can of what testing procedures you're following. And then, of course, also at post-construction, this is kind of what it looks like here. This is during the final stage of construction. You're actually going in and you're taping things up. But testing at this stage usually will ensure that all the damage, or if there's any damage that was done during like phases like the electrical phase, the painting stage, the attic insulation phase, somebody tripped over it, somebody pulled it loose, something's happened to it between the time of rough in all the way to final, you're going to catch this and fix it. I mean, I know code allows both phases of construction to be done for testing, but it always kind of gives me that not warm and fuzzy feeling of I tested it at rough in, but I'm not going to test again at final. Anything can happen from now to then. And we all know that that probably is what happens. So hopefully not. Most of the time it's found that they do it really well. But anytime the system is tested, sealing of the boots and register must be performed. So seeing tape like what you see in these photos before the sheetrock is a good sign that it's been tested. And then the one on the far right is you've got sheetrock and texture up. There's still tape on it from where it was done at pre-drywall. The sheetrocker cutting around it usually takes that Dremel tool and they cut a hole in that tape. Not a bad thing, but hopefully the testing had already been done and they don't need to have it properly sealed. And we'll talk about that center picture in a minute. There was a question brought up by a local building official, so we had need to address that at the end. But this, I know some people on here that are probably seeing this is probably laughing if they know me from my 10 years of managing a field for that, as this photo is a platform return that's being tested. The reason I show this is a matter of consistency. So if you're a rater and you're testing what we see on the left, just know that that's probably falsifying the readings of your results. Probably not by much, but it can happen. The testing of the ducts is only a test of pressure differential from the fan to the probe. So if you have to turn the fan speed higher to overcome a smaller hole that you have here, you're either overstating or understating the pressure differential of the fan and the test results. So you're getting an inaccurate test results, in my opinion. So if I was QAing someone that did this, the first thing I would do is cut the hole to the right size, is what you see on the right-hand side. I would run my test and I would record the difference that I got from what they did. So you would get basically it's a write-up in the report for QA, because in my opinion, this isn't done right. It's the same thing as if you know anything about duct testing, these systems have, they have different size openings They're called rings. They have different size openings that you put on the system to accommodate leakier ducts or not as bad of a leaky duct. Doing tape like this is basically, even though you have the fan wide open, you're basically putting and trying to force it through a smaller hole. So if you've got TEC equipment, the one on the left is like pushing it through ring 3, and the one on the right is like having it completely open, or ring 1. So if I did a QA, I'm going to be doing it like the one on the right, not the one on the left. And I did these pictures. I actually confirmed this by doing both tests. I did it one way and then opened it up and did another, and I did get a difference. So that would be a QA finding. So reasons for failure, getting some field pictures here. We talked about it earlier. We'll see those other pictures in a minute, but line sets coming into the system, openings in the casings, and then, of course, opening around the condensation lines as well. And as we talked about before, manufacturers supply grommets and gaskets for these, but a lot of times they're either thrown away, they didn't make it to the job site to begin with, and so the way to fix that is you need to put mastic on those areas, kind of like this. So line set openings, mastic, openings in the case, mastic or tape, and then condensation openings, mastic for that. So this is a great attempt at getting this to pass the first time. So we always like to see this, because that just means the HVAC installer is going one step over what's kind of required by him to try to basically get it as tight as he can. And what you're helping it do is you're overcoming some of the duct leakage that's going to happen anyways, because nothing's perfect. So you're just giving it a much better chance for passing. And then one of the more frustrating parts of a rater's job is trying to get the test. You're trying to do the test and you end up trying to fix or tape everything just to pass a duct test. This is what we talked about earlier. The code and the standards by which the rater follows for the test procedures dictate what you can and can't do. And I, as a rater, cannot sit and tape these blower covers up. I can't really tape these filter boxes or filter doors up. That is within the standards that say whatever is allowed to be opened mechanically needs to remain as such when I do my testing. Sure, I can sit and tape all this stuff up. I can get a passing number, and then I'm going to sit and take all this tape off. All that did was prove that it could be done if it was done and installed correctly, but since it's not, it should be failing and it should be fixed. So the picture on the left and the center are a blower door cover on, I think, a carrier unit. These things, as you can see in the center picture, it has a gasket, but it's not properly installed. The gasket is falling off. In my opinion, it's not the best design. I have a carrier that looks just like this, and I made exactly sure that that gasket was there and that it was sealed correctly. A lot of times the screws are hard to get in there, and so somebody just pushes it as hard as they can, and they end up messing it up. But a lot of times if a carrier unit is failing, this is why it's failing, is the blower cover is off. This crosses the line of the rater is not an HVAC contractor, therefore should not be putting tools on this equipment to fix it. And also by the standards, he's not allowed to sit and tape everything up. And then the filter door on the right-hand side, I mean, a lot of times we find it like this. The doors are bent. This is a uninsulated plenum that's being insulated on the outside with a jacket, and they're just taping the insulation to the box. It makes that door heavy, and then if you only have one clip like this one, people pull that door at the top, and it ends up bending that door, and it's just going to be leaking like this. Again, should not be taped. It needs to be repaired. Now, you could do a diagnostics and say, well, I taped all this stuff up, and it passed when I taped it up, but you need to take the tape off, fail it, and then have them fix this so it's actually going to pass with these doors being sealed shut. You won't have to do the test again as long as you can verify that door is sealed and it is fixed at final. I know that most of the time it's probably not going to be. And then the last thing, I don't have a picture of it, but heat pumps. It's just a big air handler. The electrician usually has to remove part of that panel to install the wires into the breaker that's on those heat pumps. It rarely gets screwed back on, and a lot of times the screws are just gone. They're just missing. They're not there. Again, a third party is not allowed to tape all that stuff up. It needs to be properly sealed and installed as it should be from the manufacturer. I know it's not the HVAC contractor's fault. It's the electrician's fault. But 9 times out of 10, the electrician will not be the one coming back to fix that. It's going to be the HVAC contractor that has to come back and do it. So I know a lot of third parties out there, me included, will also find the screws and try to put that back together. Technically, we're not allowed to do that. but it does save the back and forth of red tags and frustration in the field. And also another one, and again, incorrect duct size to collar size happens a lot more than you think, is they've got equipment on the truck. They're now putting in a 5-inch or a 6-inch duct, and all they have is an 8-inch collar. They're going to put that 8-inch collar in there and then just try to force the duct into it and just hope that nobody catches it. That's what you see happening on the left. This is a picture I took in the field. I think it might have been one got off of Google. But I've seen this before multiple times. And what happens is you can see that blonde looking insulation around that. The air pressure or air itself, the airflow will force its way back through the outer lining of that duct, and it's going to now have a much higher duct score. The test results are higher 9 times out of 10, meaning it's failing. And of course, most third parties won't go to the extreme of looking for this. You're just assuming they did the right thing. And then if you looked inside the plenum and you try to get a camera in there to see it, then you find things like this. That's not really ever going to pass unless it's done correctly. I don't care how well they sealed it from the outside. If air is allowed to leak through the insulation on the jacket, you've got a much higher test result. And then one on the right, I know this happens. It's a common thing. The installer ran out of the specific duct size that needs to be fixed to the boot that you see on the lower right-hand corner. He didn't have it, so they're just going to assume that someone else will come back and fix it. But showing up to a house to do a duct test and finding this, especially after you've spent an hour trying to duct test it, and now suddenly you find this hanging up in the attic, it's kind of frustrating. But these, again, you should not and you are not allowed to get up there and tape this up just to get a passing duct score. It needs to be fixed. And of course, allowing this to move forward without getting it to fix before sheetrock is probably going to be slim to none that it's going to happen. It can, but it's slim to none. And then, of course, missing ducts, bad mastic, holes in the equipment, holes in the duct is not the only reason that ducts can fail. As we talked about earlier, duct testing is just a test of pressure differentials. That's all it is. If I'm testing on either one of these ducts, I have to overcome the back pressure due to a compromised duct that's going to either understate or overstate my testing results. It doesn't mean it's going to fail automatically. It means the third party should look at this and say this needs to be fixed. But B, you're doing a duct test and it's actually it could be higher than what it normally should be if the ducts were installed correctly. So we've looked at these photos in previous webinars. We've talked about proper duct installation, but it is more than just the effect on airflow and crushing of the ductwork. It can actually turn into now you have duct testing issues that you can't get because you have compromised airflow within the system. And you've seen this one before probably too, is having electrical wiring run through and under or around or directly into a return plenum. While this may or may not be something against code, this really shouldn't be happening. It should be planned out correctly. But at the very least, this should not just have a heavy ton of mastic slapped on here to get that fixed and to try to seal it up. It should actually be have the wire reran, or at least, in my opinion, if you wanted to try to fix this the way it looks, is you cut a little notch in that and you set all of that plenum down or the return box down on that framing member and then you seal it. You don't just try to seal up a 1/2-inch gap with mastic, because we know by a fact that that will not work. It's going to try to dry and it's going to crack and it's going to leak and it's going to be more of a problem to try to work around. So these kind of things can also add to duct problems in testing. And of course, it also sometimes pays just to give the ducts a little shake when you're in the attic. Though these are probably not intentional, it does happen and things are forgotten. So there's not a collar here. The person put the ducts there. It's supposed to be done. And of course, the collar wasn't installed. But a lot of times those ducts might be sitting on there to where if you just look at that system and you glance at it, it looks like everything is set in there like it should be. And then ironically, it is not. And it's not going to pass the duct test because of the fact that it's not even attached to the system. So that's one of those things where just giving them a little tug while you're on the service deck and you're in the attic would be a good idea. And then Guadalupe says, I believe in some applications, the electrical wire may need to be different. At least it's true in commercial side. Yeah. And the reason I say that and bring it up again, I'm not sure how they do residential, but the outer jacket of that electrical wiring is unless it's a newer style wire. That stuff, if it burns, melts, or gets super hot and starts to smoke, it gives off contamination. It's kind of a really bad gas that can get into the duct system. So not ever a good idea for having electrical wiring in or through a return box or a supply. It rarely happens with supply. I don't think it would ever happen unless you're trying to do something wild and crazy with the supply. But that's a good point. I'm not on the electrical side code. I don't really know what that says, but it probably says not to put it in the airstream because of the toxicity of the outer jacket. And just a couple more here. We got no mastic on the collars, and the ducts, as you see on the right-hand side, are not connected on a subfloor duct. And so this is, once it's sheetrocked, there's not really accessibility to fix this. So this is one of those things you would have to, unfortunately, you're just going to have to fail the test, not be able to pass it. They won't be able to sheetrock. You got to wait till that's fixed. This probably means that the person just was going to do it and just forgot. Maybe it was pushed up into the subfloor. It looks like it was connected, and then it wasn't. And then on the left, you can see there's no mastic on that collar at all. Actually, there's mastic on the Mylar lining, but not on the collar, which means they just slipped that Mylar inner lining on it and then try to mastic around it to make it look like it was sealed. This happens way more times than you think it should. So just QA, QC, looking at the field work and looking at contractors and making sure that those guys are doing it. Doesn't mean the company's bad. There may be one guy that just got hired that came from a different company that's kind of how he did it, which is the same thing we see here. Again, mastic all over the duct, nothing on the collar. It looks sealed from the outside. I know a lot of cities want to see up into a return at least and see mastic inside that return where it connects to the boot. I know Dallas is one of them that says you're not going to cover it or you're going to cover it with something clear so that they can see mastic on the return boots where they're actually having that mastic properly set on there. But two things there: the mastic not thick enough. I mean, I know they did it on the outer Mylar. That's A, not right to begin with. B, it's not thick enough. They do have a zip tie that's on there. I think it's been cut. But just a poor way of doing a supply here, and this is one that you'll end up finding out that's why you're failing a duct test. It looks sealed, but it's not. And then the one on the right is just disconnected in the crawl space. So just using tape and a zip tie and no mastic on those collars, not a good sign. And then lastly, beyond duct testing, there are additional tools that we can use in the field looking for duct leakage as well. So here you see on the left-hand side an infrared camera being used to visually verify the leakage around the collar at a supply plenum. And the image on the right is the result of that leakage. So it's basically building up heavy condensation. It's causing mold growth around the collar. And more than likely, it probably is also happening inside the plenum as well, making its way into the airstream that makes its way into the house. So in my opinion, having insulated jackets masticed to the collar and or plenum and not be able to lift them back and look inside to make sure that it's properly mastic on the collar before the liner gets put on, to me is key. I know there's a lot of HVAC contractors out there now that are masticking the insulation to the collar itself, and that may be something that somebody's requiring. But if you're not doing the inner lining correct to begin with, you're going to have a major problem. And then, of course, miscellaneous item. I talked about this picture a little bit earlier. This photo comes from Logan with the city of Rowlett. Thanks to Logan for that question and photo. Basically, he was saying, hey, is that too close to an exhaust fan? And of course, we look at it and, well, that's a supply boot. That's not a return. And so according to the code, there's no specific requirements against putting supply vents near exhaust fans. They have throw and velocity to them that should make it past any CFM 80, 50 CFM fan. It should make it past that. This is a very small bathroom. There probably won't be an issue with it. But after talking this over with him, I said, look, there's nothing saying that you can't. The best practices is I wouldn't recommend it being the throw towards the vent. In other words, if I was installing it, I would have turned that vent 90 degrees and just had that vent grill facing either the outside wall or the wall that's actually an opening of a door. You probably wouldn't want to do that because now you're blowing air out of that room itself. You're not conditioning the room that it's in. But as you see, return ducts and return boxes, those do have requirements by code. It must not be installed within 10 feet of a draft hood and or exhaust fan. That comes from the mechanical code M1602.2. So from a building science standpoint, the supply air should be pointed at the direction of the heat load, and that one in this case would be the exterior wall. Um, if this vent was turned 90 degrees, you could have that vent put in to where it actually blows against the wall. You really don't want it blowing directly on someone. So if that bath fan is installed, A, it's installed poorly with how the duct is running. B, if that's directly over the water closet, the toilet area, and that vent is now pointed directly at their head, that's probably not going to be very comfortable. There's just not a lot you can do with this, except, in my opinion, you'd point it towards the outside wall. And so, as we said earlier, the IRC in that chapter 16 addresses the location of returns. So also returns can't be put in closets, bathrooms, toilet rooms, kitchen, garage, mechanical rooms, boiler rooms, furnace rooms, or unconditioned attics. So that's really what it also chapter 16 specifies for return areas. You shouldn't have them in those locations. And then it says, and that's one thing that and again, I'm not an HVAC technician guy. There's some encapsulated houses with foam that people are also putting returns in. In my opinion, that's not really a good idea, although those are probably sealed furnaces, 90+% furnaces that are sealed combustion and sealed venting. All you're really doing is pulling air from the attic itself, but that's probably may not be a good idea to do that. And then, of course, mechanical ventilation. I bring this up a lot just because I think it's still a good point to bring up for mechanical ventilation. We've seen several webinars on mechanical ventilation. We call it fresh air. There's various ways to meet code. One is a balanced system, which is what we see here. So the equal amount of air going into it's also the equal amount of air that's going out. Keeps the house at a pressure balance. So as we said in the beginning of the webinar, if you have duct leakage, you have pressure imbalances throughout the house, airflow imbalances throughout the house. And now, of course, you mix mechanical ventilation into it, and either you're doing one or the other or a balanced. Balance is always the best way to go, but they're the more expensive way of going. And of course, then we have supply and exhaust only. And of course, either of these can be used, but in the warm, humid side of the country, it's not best to exhaust it because you're actually pulling humidity in through the wall cavity, creating a possible condensation point in the wall. So supply will be putting more air into it, as you see on the left, and it's just diluting the contaminants while the exhaust is actually pushing out contamination. Either are acceptable. You know, if I was in a dry climate, I'd want to push it out because I don't want it there to begin with. But if you're in a warm, humid climate, you'd probably just want to dilute it to the parts per million comes down to a healthier level. And then, of course, as code states, if mechanical ventilation is part of the duct system, if it's tied into the air handler, it must be duct tested. It's not excluded from being tested. These cannot be taped. They cannot be closed. They need to be left as they're going to function. If it has a mechanical damper that opens and closes when not in use, that damper should be closed. But if it has a hand like a damper that actually has to be done manually, you shouldn't get up in the attic and close that. If it's going to be left open at all times, you need to test it as it is. And then, of course, some common sense reasons of failure, again, is compromised ductwork. We talked about that earlier, is if you see a duct that looks like that on the left, it's not going to get the best chances to pass. And now in the 2021 and beyond, with mechanical ventilation being required to be tested, you're just setting this up for failure. So I know the one on the left it's coming out of the attic. It exits the ceiling. It comes down the outside wall. A chase now has to be built to enclose the duct. However, the duct is already compromised, and 9 times out of 10, when they build this chase, they're going to be told to build the smallest one that they can, which means they're probably going to crush this ductwork. This really shouldn't be allowed to be done that way, but it does happen a lot. And then, of course, the photo on the right is the exhaust fan. If you're using this as mechanical ventilation because you're on the dry side of the United States, this always works out to where the electrician installed the box and the HVAC guy has to run the duct. So the electrician installs it to run the shortest amount of wire, and now the HVAC guy is left with having to run the duct backwards or at 180 degrees or something. This fan, probably an 80 CFM fan, if I could tell by the way the box is deep, and it's a 4-inch duct, and I can see it running up to the right, which means it's probably going to be a kind of a lengthy run. That's probably not even going to push 50 CFM looking like this. This would need to be fixed for Energy Star, and now in 2021, when you're doing mechanical ventilation verification of fan efficacy, it'll have to be tested and found out that if it doesn't pass, that means it's going to have to be done again. So there again, when there's no way to fix it without cutting sheetrock, but you have to have it hit 50 CFM to pass, you're probably not going to get there. So I don't know. I don't know the fix to this when you've got two different contractors installing one and or the other, but they need to communicate to where they're installing it to the best success of the airflow. It may take another foot, foot and a half, 2 foot of wiring, but really this should not be a wiring issue. It should be an airflow issue. So meaning that should be the priority is the airflow, not the wiring. So being installed this way is more than likely not going to pass. And then lastly, with the 2021 IECC mechanical ventilation now being tested by an approved third party, code requirement allows for various testing equipment that can be used. When this first came out and we were doing testing, the only thing we have to be able to test, especially if you're using a Honeywell YD150, is you're cutting into the ductwork. That's not the best choice, but as you see, if you don't prepare the duct to be cut first, as you see the one on the right, it completely shreds the inner mylar, and the duct just comes apart. And so when that happens, then you've got unwanted, in my opinion, you've got unwanted fibers from the insulation, and or the attic air itself is what's coming in as fresh air, and that's nowhere near to be fresh air. So thankfully, though, the manufacturers have now caught up. They have inline test ports. They have static pressure points that you can actually attach hoses to, and then you can convert that to CFM using some of their tables for converting. But like I said, this was kind of an earlier, only way we can do it. When it first came out, it was proposed that we have a test station by the mechanical installer is putting a hard pipe in with a hole in it that we could test without cutting into ductwork. That was not approved. So we're just left up to our own devices to try to figure out how do we get this to work. And how we get it to work is we try to prepare the duct for surgery. We always called it open heart surgery. Put tape on there first, cut through the tape. That way the duct holds itself together. But a lot of times guys will forget that. And when you take that probe out, it just ends up shredding the inner liner of that duct. So that's kind of mechanical ventilation for that part of it. I thank you guys for being here today. Join us next week. We're actually going to dive into HVAC grading. It's called an ANSI 310 standard. It's actually for, in my opinion, it's kind of what's coming in the code probably way down the line, but it's in HERS and it's in Energy Star. If a home is following Energy Star, they're doing HVAC grading. It's basically the third-party energy verifier is validating the installation of the equipment, and they're giving it a grade. So we're going to look at the overview of the ANSI Standard 310, the purpose, the scope, the key components, including the duct system performance, refrigerant charge verification, and airflow assessment. That's the three big things you have to do. And of course, how does HVAC grading affect energy ratings? So learn how proper installation and verification can impact the home's performance. And then, of course, best practices for compliance and implementation. There's a lot of going back to the drawing board and relearning from an energy standpoint from a third party of now you have to do watt draw and you have to do airflow and differently than just doing a duct test. And so that's something different to look at. So and Guadalupe, so you just said, and then the duct is not taped well and it will come apart. That's exactly right. That tape is only good for a certain point, and once you get attic temperatures of a big swing, that tape starts to come apart. So, in my opinion, not the best idea to do heart surgery on ducts. We just weren't given another option until those inline fans came in. If you're still doing the Y8150s, if you're in an area that's 18 or prior, 15, 12, 09, then if you have mechanical ventilation, then they're going to be doing open heart surgery if they need to test it for Energy Star. However, if you have 21 and beyond, you really need to be having these inline fans that come with test ports that you don't have to do that. So again, thanks for everybody being here. Here's my contact information. Please feel free to reach out to me with any questions you have. Please feel free to share this with anybody if they need my help or assistance with anything. And then, of course, if you want to connect with us, here's kind of our main number, our website. We're on LinkedIn, X, and Blue Sky now as well. So thank you guys very much. And as I said before, this will be posted on YouTube probably, hopefully within 72 hours. So if you want to have someone to rewatch this, great. You won't get ICC CEU credits. You have to be present to do that. Otherwise, it's still a good learning tool for your departments. So thanks, guys, for being here.